Section 1.1, the slope of a straight line. So the truth is all you need is two pieces of information and you can draw a straight line. It's possible that you use 2 points, but for us we're going to just say that we can completely determine a line if we know a point and if we know a particular slant, and that slant is called the slope. Well, we need to be able to calculate slope, but let's derive it real quick. Let's pretend that I have 2 points on a coordinate plane. Well, let's just label them, but since I don't know what the ordered pairs would be, then let's say it's x1, y1, and the point x2 and y2. Well, the truth is that those 2 points do create a line. Pretend that I drew a straight line. So then we have a line, and we want to know how much change actually occurs. Well, I claim that if you could find how much changed in the x values and how much change happened in the y values, then you would know what they were. And so if x1, y1 and x2, y2 are on the line, then the slope is going to be what? Well, the change in x and the change in y. Well, specifically the way we're going to define this is by some letter m, and m is just going to represent slope. And then all we need to do is make a decision about how we're going to define this slope, and we're actually going to define it as rise over run, or that is the change in y over the change in x, or you can do that as the differences in the y's over the differences in the x's. And so that's what we're going to take to be our slope. M is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, like I said, we can think of this slope as what we're going to be calling a rate of change. That's a rate of how quickly it changes. And specifically, once again, the slope is the change in y over the change in x, which is how much does it rise over how much does it run. And I'm thinking run is horizontal. Well, then a couple things as a reminder. Given a slope, m, and a point, where that point is x1, y1, then I know that technically any other xy point will have to satisfy the equation, that slope equation, m is equal to y minus y sub 1 over x minus x sub 1. This has to be true. Well, if that's the case, well then we get this linear equation. I can multiply both sides by that x minus x sub 1. Just to do a little bit of algebra here. And if I multiply both sides, then what I'll get is this formula, that is m times x minus x sub 1 is equal to y minus y sub 1. Well, we're actually going to call this the point slope formula. Okay? And it's the point slope formula because if you take a point and the slope, you can put it into this equation and you can get an equation for the line. Furthermore, we also have another good way to represent our lines, that is given the slope m and the y-intercept, and specifically we're going to say that y-intercept is the point 0b, because we don't know where it's going to be necessarily, but we know that it has to have an x value of 0 because of course that's the y-intercept. Then you could apply the point slope form where x sub 1 y sub 1 is equal to 0b. And then if we do this, we'll get the equation from the point slope form of y minus b is equal to m times x minus 0. And then if you add b to both sides and distribute the m, you're going to get y is equal to m times x, add b to both sides, plus b, and so we get this thing called the slope-intercept form. Alright, y equals mx plus b. So then, let's use these examples to find some information. Let's find the slope and the y-intercept for each one of these equations. Well, notice that the first one is in slope-intercept form. So I'm actually going to get the slope for free, because if it's y equals something times x minus or plus a number, I know that the slope is the coefficient of x, so my slope is going to be 4/3. That's that rate of change for that line. Then I can also get b, the y-intercept, which is going to be -32. And remember that sometimes you might need to write this as an ordered pair, and so 0b is of course going to be 0, -32. And so that's the y-intercept. Now for number 2 here, 2x plus 3y equals 19, well, first off, if we want, we can just put in slope-intercept form. And so if we put it in slope-intercept form, what could we do? We solve for y. So how about I subtract 2x, subtract 2x, that's going to give us 3y is equal to -2x plus 19. Then I could divide everything by 3. That's going to give me y is equal to -2/3 x plus 19/3. Then at this point, we now can say, oh, well now I see that the coefficient of x is -2/3 and the slope is that, -2/3. Whereas my y-intercept is going to be 0, 19/3. So there is our slope and our y-intercept. Lastly, this one says we're going to have a line passing through the points 1, 3, and 4, 9. Well, what could we do? Well, first off, notice that we're not given a y-intercept. If we were given a y-intercept, we'd be done, but we're not there. So what can we do? Well, you could use the slope formula. You could say that m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You just need to assign values for these things. How about we call this x sub 1, and then this would have to be y sub 1. And then if that's the case, let's call this x sub 2 and this one y sub 1. Excuse me, y sub 2. Now, you could of course swap the 2's and the 1's, but make sure that once you pick one of them to be the 1's and the 1's, you have to keep them that way, and the other one has to be both 2's. So this is then going to be 9 minus 3 divided by minus 1, and that's going to give me 6 over 3, or a slope of 2. So my slope is 2. Great, that was the first thing we needed. Well, at this point, what could we do to find the y-intercept? Well, if you wanted to, you could graph it, but we're not going to do that right this second. Instead, let's use the point-slope form. Now you may be asking, which point should we use for our point-slope form? The answer is it does not matter. Just pick your favorite point. I'm going to use 1, 3, but if you use 4, 9 and you do the algebra, you should get the exact same slope-intercept form that I get. So y minus 3 is equal to 2 times x minus 1. So then let's solve this thing for y. This is then going to be y minus 3 is equal to 2x minus 2. Add 3, add 3. We then get that this is y is equal to 2x plus 1. Notice that this actually confirms that we had our slope of 2. Great. And now we get the y-intercept 1. So now I know that my y-intercept is 0, 1. Alright, now let's sketch some graphs. So first, we're going to have to sketch a quick XY coordinate plane. Truth is it can be a little rough when you're sketching by hand, but be careful because, of course, we're not computers, and unless you're a really great artist, you're not going to get really straight lines. So, what can we do? Well, first off, let's graph a line with a slope of -4/3 that passes through the point -2, 1. Well, how does that work? Well, let's plot the point -2, 1. Well, that's -1, -2, and then it goes up 1, so we get a point right here. Well, then this is where it gets kind of strange, because remember that our slope m here is -4/3. Now, they have written the negative out front, but there's two options here. The negative can go on top, or the negative can go on bottom. Now the approach here can differ, because remember that this is the rise over the run. That's how much change in the y over how much change in the x. Well, positive change is going to go up or right, and negative change is going to go down or left, depending upon if it's in the numerator or the denominator. Well, let's look at this. This can actually go two ways, but we're going to see that it won't matter. They both give us the exact same answer. So, starting at the point -2, 1, let's try this one first. Let's go -4, so that's down 4. So I'm just going to guesstimate 1, 2, 3, 4. So we went down 4. Then we're going to go right 3. 1, 2, 3. Now if I were smart, I would have really given myself more tick marks, but for the sake of argument, we're just sketching, and so this is okay. Well, now let's change it up and let's do the other one, just to verify, because the truth is I claim that if this works out, the line that we can draw should match up with this point, the starter point, and whatever point we get from 4, -3. And so let's use 4, -3. We'll start at that first point, that -2, 1, and then let's go up 4, because the positive 4 is on top. So 1, 2, 3, 4. All right? Then the bottom says -3, so we're going to go left 3. 1, 2, 3. Well, I claim that if we can draw a straight line through this, we're good. Now, it's a rough sketch, and if I had graph paper, this would be far superior. But I claim that this works. Doesn't matter which way you go, as long as you get a starter point, you can use the slope and you can go in multiple directions. Well, let's try this next one. But I'm going to make my life a little bit easier. I'm going to put this in slope-intercept form. The way that I'm going to do that is I am going to subtract 2x. Subtract 2x, that's negative. Y is then equal to -2x minus 3. At this point, divide everything by -1. We're going to get that y is equal to 2x plus 3. Notice now that my y-intercept is 3, or specifically the ordered pair, 0, 3. And then my slope is 2, or 2 over 1, because you can always write a whole number as a fraction. So, since that's the case, let me give myself a new graph. So let's do this. I'll give myself a few more tick marks this time. How about 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we have our starter point, which is the y-intercept. So 0, 3. Alright, there's 0, 3 right there. Then my slope is 2 over 1. So what does that mean? I could go up 2, 1, 2, and I can go right 1, right 1. There we go. Now I said we can go multiple directions. How can you do it with this one? Well, 2 over 1 could also be written as -2 over -1, right? Because -2 divided by -1 is still positive 2, so that's really the slope of -2 over -1. So we could go down 2, 1, 2, and left 1 because of those negatives, and notice that this line that we have now is just fine. So now for parallel lines. The deal is that if we have two completely different lines, and they have the same slope, so if they're not laying on top of each other and they have the same slope, well, those two lines are parallel. Matching slopes create parallel lines. When two lines are perpendicular, except for the case where you have a vertical and a horizontal line, if you multiply the slopes of those two lines and you get -1, then that's going to mean that you have perpendicular lines. Now there's this different way to think about that, and that is if you have the slope of one line and you want to find a slope of a perpendicular line, then the perpendicular line will have an opposite sign reciprocated, reciprocal meaning flip the fraction, slope. Okay, so let's do this. We're going to find lines parallel and perpendicular that pass through a specific point to a specific line. So we want to find a line that's parallel to y equals 1/3 x minus 2 that passes through the origin. Remember that the origin is just the point 0, 0. And so then parallel means that we're going to have a matching slope. Well, our starter slope is 1/3. And so that means that the slope we want for parallel is the same, 1/3. Well, if we pass through the origin, notice we get a little bit of a cheat here. This is the y-intercept. the y-intercept is 0. And so now I know that b is equal to 0, 0, or specifically just 0, which means I can jump straight to the parallel form, which is y is going to be equal to 1/3 x plus 0, but of course we don't have to write plus 0, and so that's our parallel line. Y is equal to 1/3 x. Well, now let's try perpendicular. So for a perpendicular line, take the slope you're working against. Take the opposite sign reciprocal. So 1/3, flip it, that's 3/1, and make it negative because it was positive. That's the slope we want. The slope we want is -3. Well then, once again, we've gotten the y-intercept already for free, so might as well not work ourselves to death. That's going to be y is equal to -3x plus 0, because -3 is a slope. This is slope-intercept form. 0 is the y-intercept, but of course we don't have to write plus 0, so we can erase that, and that is our perpendicular equation. Let's try it again. Let's find a line parallel to the one given. So we have y equals 2x. This is in slope-intercept form, which means that our slope for our starter line that we're working against is 2. So that means for our parallel line, we want the exact same slope. M is equal to 2. Well, now it's going to pass through the point 2, -3. But notice that this is not the y-intercept, and therefore we can use the point slope form. So we can let this be x sub 1, y sub 1. And then that's going to be y minus -3, be careful of those signs, is equal to 2 times x minus 2. And then that's going to be y plus 3 is equal to, distribute, 2x minus 4, which then is y minus 3 is equal to 2x minus 7. And so that is the equation of the parallel line. And then if we want perpendicular, you take that starter slope and you change the sign and you reciprocate it. Well, 2 is really the same thing as 2/1, right? So to reciprocate that, it's going to be 1/2. Then change the sign so we make it negative, and that's going to be the slope for the perpendicular line. And then we can still use x1, y sub 1 the same way we just did and use point slope form. So that is y minus -3 is equal to -1/2 times x minus 2. We can solve for y if we want it in slope-intercept form. So let's clean it up a little first. That's going to be y plus 3 is equal to, distribute the -1/2, -1/2 x. -1/2 times -2 is going to be positive. Half of 2 is 1. And so then I can subtract 3. That's then going to be y is equal to -1/2 x minus 2. Now I'm putting these in slope-intercept form just out of habit, but it's not necessarily required depending upon how they want you to answer the question. So if they say find an equation, you would be done. If they said find an equation in slope-intercept form, you would have to do it like I did it.